Hello students, this is SUJATAG coming with our new channel 10th NCERT SSC Maths with Sujata ji. Welcome in our channel. You get 100% success in maths. So students, before half yearly exam, glance through it. Hello students, today we are going to learning about the chapter 1 real numbers in 10th NCERT Maths. Now in this chapter, there are the three topics. First, introductions. Second one, fundamental theorem of arithmetic. And the third, revisiting and irrational number. So let us see the first introduction. In this introduction, first we have to see about the Euclid's division algorithm. So काय आहे Euclid's division algorithm? ते आपण बघूया. What is the statement of this Euclid's division algorithm? It states that any positive integer a can be divided by another positive integer b in a set in which way that it leaves a remainder and that remainder should be less than b. Okay? Meaning, what is the meaning of this? Meaning of this is if there is a positive integer a and which divided by any other positive integer b in such a way that it leaves the remainder. This is the remainder and here the quotient. Now we know that, we always know that is the remainder should be less than b. So hence Euclid's division algorithm ला सांगायचं आहे that if any integer a can be divided by another positive integer, then it leaves remainder and that should be smaller than b. Now what is the use of this? Now this is the process of long division. So we can say that this Euclid's division algorithm is applicable for the long division process. And the second use of this is to find out the divisibility of integer. If you want to find out the divisibility of integer, then this Euclid division algorithm is applicable. And the third one, that if you find out the HCF of the two given integers, then also it is applicable. Okay, got it, students? Now come to the next point. The fundamental theorem of arithmetic. The fundamental theorem of arithmetic. काय सांगतो हा fundamental theorem of arithmetic? What is the statement of this? It states that if any composite number can be factorized as a product of prime numbers in a unique way, except for the order in which the prime occurred. आता what is the meaning of this statement? काय आहे ऍक्च्युअली याचा meaning? या स्टेटमेंटचा meaning असा आहे की जर समजा if there is any composite number, तुमच्याकडे composite number आहे and you have to factorize it, तुम्हाला त्याचे फॅक्टर काढायचे आहे, तर तुम्ही काय करणार? You factorize it, but do not matter as you factorize that the order of the primes, either that will be ascending order or that will be the descending order, do not matter with it. Okay, so here take example to clear this theorem. So there is a number 210. So I factorize this number with a simple way. I know that this 210 is divisible or the factorized as 21 tens are. Okay, very simple and short way. So now, then I factorize these 21 in a 3 sevens are. So 3 multiplied by 7. Now I factorize the 10. So here 2 5s are 10. So here that the factors of 210 is 3 into 7 into 2 into 5. So here, these primes, we get these primes, but see, observe these numbers, observe these primes. These primes are not in a ascending order. So after that, after factorizing this, you can order in a ascending way. So you may write 2 into 3 into 5 into 7. This way also. So do not matter about their ascending order of the prime numbers. So हेच आपल्याला कोण सांगते फंडामेंटल थेरम ऑफ arithmetic सांगतो that do not worry about the order in which the prime occurs. Prime numbers कसेही फॅक्टराइज केले कोणत्याही ऑर्डरने असले तरी चालेल फक्त only you do the factorize of the composite number in a proper way, in a right way. Do not do the mistake to factorize it. Now suppose that 210 other any students can do this process, that is a 10 multiplied by 21. Okay, then factorize this 10, 2 5s are 10. And then factorize 21 as 3 multiplied 7. Okay, do not matter about the product of the order of the prime occurs. Okay, so हेच आपल्याला हा फंडामेंटल थेरम ऑफ अरिथमेटिक सांगत आहे. Okay, clear about this topic, the fundamental theorem of arithmetic. Then come to the application. Then where the fundamental theorem of arithmetic is applicable. Only there are the two applications. First one, this theorem is applicable for to prove the irrationality of many of the numbers, any of the number. Suppose there is a number and that number is either rational number or irrational number. So we can prove that the irrationality of this given number. So this is the application, first application of the fundamental theorem of arithmetic. Then the second, this theorem is applicable for the decimal expansion of a rational number, is useful for decimal expansion of rational number. You know that what is the rational number? That rational number means any number which is of p upon q form. P, q are integers, q is not equal to 0. So such a number is called as the rational number. And you also know that what are the irrational numbers? The numbers which is not in the form p upon q, where p and q are integers and q is not equal to 0. Then such a numbers are called irrational numbers. So remember this point, that the fundamental theorem of arithmetic is applicable for to prove the irrationality of any number and to find out the exact decimal of the rational number. Okay, got this point? Now we have to factorize the smaller number. We can factorize the smaller number and the larger number. The easy way we can find out we can factorize the smaller number very easily. That suppose 2, we can factorize 2 as a 2 multiplied 1. 4 as 2 multiplied by 2. 253 is still the smaller number, and it is also factorized that 11 multiplied by 20. We can factorize very easily and short way that the smaller number. But what about the larger number? Largest number? That is the difficult task to find out their factor. Okay? So, very easy way that I can teach you. First, there is a large number. Take the large number 10,626. First, या 10,626 ला काय करा? Smaller number बनवा. Become a smaller number. So, see the unit place. So, 6 is the unit place of this number. So, of course, that number should be divisible by 2. So, I factorize this number as 2 multiplied by 5,313. Then here, I factorize this number. So, this number 10,626 becomes smaller and convert into smaller number 5,313. Then 5,313 is still bigger number. So, I convert into the smaller number, again smaller. I factorize it. So, I know about that. This 5,315 is divisible by 3. So, if factorized by 3 multiplied by 1,771. Then again, this 1,771 factorized. I know that 1,771 is divisible by 11. This number is divisible by 11. So, factor of this 1,771 as 11 into 160. Again, I factorize 161 as I know that the 161 come in the 23 table. So, I factorize 23 sevens are 161. So, as a 7 into 23. So, this way, finally, I got the factors. So, 2 multiply 3, multiply 7, multiply 11 and multiply 23. I arrange. This is not the ascending order. Except order. This is the state where I couldn't see the order of the primes occur. I write as it comes, as the number divisible by any number. But last step, that is the order. I arrange in a ascending order. Okay, I arrange the prime numbers in a ascending order. So I take the last step, 2 multiplied by 3 multiplied by 7 multiplied by 11 multiplied by 23. Okay, this way we can factorize the 10,626, which is the biggest number. Now let us see the second example to clear out this point very clearly. Okay. Now here second example 8,232. It is a largest number. So I see the unit place digit, unit place there is a 2. So this number is divisible by 2. So the factors are 2 into 4,160. So here 2 multiply 4,160. So now at the place of this unit place there is a 6. So it is also divisible by 2. So the factor of this number is 2 multiply 2,058. So again I see the unit place number. So which is divisible by 2. So this number is divisible by 2 and take the factor 2 into 1029. Again here the number is 1029 and I see the unit place number which is the 9, but I know that 1029, so that unit place number is 9, so it is not divisible by 2. So I go further, and I know that this number is divisible by 3. So this way it factorizes 3 into 343. Now here I get the number 343. I know that 343 is the cube of the 7. It is the cube of the 7. So I directly factorize this number. That is 7 into 7 into 7. Okay. So this way I get the factor of the 8232 as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 7 multiplied by 7. So this way one can factor the biggest number in a very easy way and in a short way. Now students, take the third example, which is the biggest number, 21,252. Now see the unit place number. So the unit place number, here the unit place number is 2. So this number is divisible by 2. So I get the factor 2 multiplied by 10,626. Now 10,626 आत्ताच आपण केलेला आहे, त्याचे फॅक्टर्स पण दिले आहेत. So I know that the factor of the 10,626 as 2 multiply 3 multiply 7 multiply 11 multiply 20. Yes. So very easily we can find out the factor of the largest number. So now here, what are the factor of the biggest number 21,252? That is 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 11 multiplied by 20. But now, as this is the product form, but as I want this product in a power form, I represent these primes in a power form. Then I write this as 2 comes 2 times, so I write here 2 square of 2. 3 is 1 time, so I write 3 raised to 1. 7 come 1 time, so I write here 7 raised to 1. 11 come 1 time, so I write 11 raised to 1. And 23, that is 23 raised to 1. So this way we get an infinite collection of numbers and all the primes and all the possible products of primes. So this is the simple and easiest way to factorize the biggest or the largest number. So हा पॉइंट क्लिअर झालाय तुम्हाला? तरी सुद्धा आणखी बिगेस्ट नंबर आहे त्याचा आपण फॅक्टराइज करूया. ओके, सो फॅक्टराइज, द क्वेश्चन इज फॅक्टराइज पॉझिटिव्ह इंटिजर्स 32,760. Okay. So now I know that there I see that the unit place there is a 0. So this number will be divisible by 2. But as I observe this number, then I identify that number that should be divisible by 30. So I factorize this number first as 13 multiplied by 2,520. So I get the 2,520 as the biggest number, and I factorize this into 10 multiplied by 252. Then factorize 10 as 2 5s are 10, and then factorize 252 as 2 multiplied by 126. Then again here, these are prime numbers. but 126. Factorize the 126, which is a composite number. So factorize 126 as 6 into 21. There is no matter that which number you take first. You take any way which is easy to. इथे तुम्ही विचार करू नका कुठला नंबर आपण पहिल्यांदा घेतो. सिरियली असेंडिंग ऑर्डरने आपल्याला नंबर घ्यायचेच नाहीये. आपल्याला इझी वे बघायचा आहे आणि शॉर्ट वे बघायचा आहे की आपल्याला फॅक्टर्स त्या बिगेस्ट नंबरचे फॅक्टर्स आपल्याला पडले पाहिजे. ओके, सो नाव 21 is factorized 3 7s are 21 and then 6 adds up 2 3s are 6. Now here up to this stage we'll get the primes in a product form, but now I arrange these primes in a ascending order. So here the product as a product of primes in a ascending order, that is 2 multiply 2 multiply 2, 3 multiply 3, 5 multiply 7 multiply 13. But now as well as we can arrange these primes as a product of powers. So here powers च्या फॉर्म मध्ये तुम्हाला शो आउट करायचे प्राइम. So here 2 comes 3 times. So I write here cube of 2. 3 comes 2 times. So I write square of 3. 5 comes 1 time. So I write 5 raised to 1. 7 come 1 time. So here 7 raised to 1. 13 come once. So here 13 raised to 1. So 2 cube of 2, square of 3, 5 raised to 1, 7 raised to 1 and multiply 13 raised to 1 as a product of powers of primes. Okay, so this way we can factorize this number 32,706 with very easy and short way. Okay, so असेच नंबर जर बिगेस्ट आले तर तुम्हाला अगदी छोट्या छोट्या पद्धतीने तुम्हाला जो टेबल येतो त्या टेबलनुसार तुम्हाला काय करायचे, डिव्हिजिबिलिटी टेस्ट जी आहे ती त्या नंबरची अप्लाय करा आणि ती अप्लाय केल्यावर तुम्हाला काय मिळेल, तो नंबर, तो प्राईम नंबर तुम्हाला मिळेल. सो नाउ नेक्स्ट वन, नेक्स्ट एक्झाम्पल, सी द बिगेस्ट वन number, that is the 1 2 3 4 5 6 7 8 9. We have to factorize this number. Okay, so now here this is the biggest number and I know that this number is divisible by 3. This number is divisible by 3. So the factors of these are 3 into 4 1 1 5 2 2 6 3 6 3. Okay, then I factorize these 411, 522, 63 as which is divisible by 3 again. Then the product will be 3 multiply 1371 7421. So now here 1371 7421, this number, the factor of this number is 3803 multiplied by 3607. So this way, this is the product of prime forms and this is the product of powers of prime, because 3 comes 2 times. So I write here square of 3, 3803 and multiply 3607. So now here 3803 and 3607 are the primes. Okay, so this way the biggest number can be converted into the smallest number. Okay, so तुम्हाला product form, power form जो प्राइमचा असेल त्यानुसार तुम्हाला इथे प्रॉब्लेम सॉल्व करायचे आहेत, फॅक्टर्स तुम्हाला करायचे आहेत. ओके, सो नाउ लेट अस सी द थेरम. 1.1 in your textbook, that is the fundamental theorem of arithmetic. The name of this theorem is the fundamental theorem of arithmetic. So you know that very well. What is the statement of this fundamental theorem of arithmetic? That is that every composite number can be expressed, or expressed, that means factorized, as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay, so now we know that every composite number factorized, but that factorization, that factors should be expressed in a unique way, that can be factorized in a unique way. Okay, and that will be, there is a specific way you can factorize, you can express that composite number, and you know that that unique way is the product of ascending of prime numbers. So this is the unique way. So now here, do not mention or do not worry about that order, as while factorization of this biggest number, do not worry about their order. Okay, so now also this statement, also this fundamental theorem says that means every composite number can be factorized as a product of primes. Also, we can say that any composite number, it can be factorized as a product of prime numbers in a unique way, except for the order in which the primes occur. म्हणजे इथे हेच सांगतोय की कोणत्याही कंपोजिट नंबर्स असतील तर त्याचे फॅक्टराइज पडतातच, त्याचे फॅक्टर्स पडतातच हे काय. आणि त्याचबरोबर हे जे फॅक्टर्स पडतात आहे, जे फॅक्टर निघतात आहे, तर ते फॅक्टर कसे होतात आहे, तर ते युनिक वेने आपल्याला फाइंड आउट करायचे. पण एक आहे फॅक्टर करताना, फर्स्ट फॅक्टर करताना तुम्हाला त्यांचा ऑर्डर हा विचारात घ्यायचा नाही. ऑर्डर न विचारात घेता तुम्ही त्यांचे फॅक्टर काढा आणि नंतर त्यांचा युनिकनेस जो असेल तो तुम्ही काय करा, तिथे असेंडिंग ऑर्डर हा त्यांचा युनिकनेस आहे, तर त्या युनिकनेसने तुम्ही काय करा, त्यांचे प्रॉडक्ट्स फॉर्म करा. ओके, सो हेच फंडामेंटल थेरम ऑफ अरिथमेटिकला सांगायचं आहे, दॅट एनी कंपोजिट नंबर कॅन बी फॅक्टराइज्ड इन अ युनिक वे, ओके, एक्सेप्ट their order of primes occur. So down here, that given any positive number, there is one and only one way to write it as a product of primes. Yes, there should be the one way, that is the ascending order. You can factorize this number. Suppose take the examples 210. So we get a factor as 2 multiply 3 multiply 5 multiply 7. As well as any other students can be write 3 multiply 5 multiply 7 multiply 2. Okay, or there should be the another possible order in which the primes will be occur. So this way you can factorize in a unique place or in the ascending order. Okay, got these points clear out? Students, thanks for watching our videos of 10th NCERT Maths. Keep watching our videos continuously. We'll sure that you will get 100% success in Maths. So, like and subscribe our videos